Compared to Venus, Mercury is even closer to the Sun and is in its gravitational field, which is larger than that of Venus. Then it should actually turn backwards because of the differential gear effect as in her case. In reality, however, it rotates prograde. How can this phenomenon be explained? The difference between Venus and Mercury is that Venus' orbit is almost circular while Mercury has an orbit with a very large eccentricity. From the principle of the Moon's orbit we know that it has deviated from its circular path and is about half outside the base circle. In this half-orbit, the lunar orbital speed is less than the orbital velocity. On the other half, the Moon runs within the base circle and its orbital speed is greater than the orbital velocity. This principle also applies to planetary orbits. As we already know, when a planet's orbital speed is greater than its orbital velocity, its speed is slowed by the Sun's gravitational field. The braking force is also stronger at point A, the side facing the Sun, than at point B, the side facing away from the Sun. This causes a prograde rotation. This means that if a planet moves in a non-circular orbit without its own rotational force, it could be propelled to rotate in one direction in some places and in another direction in other places. Also, because the planet has rotational inertia, the rotation will eventually stabilize in one of the directions. Depends on who has the upper hand. When Mercury is at point 7, it is running at exactly the orbital velocity. As explained in the previous video, its rotational angular speed is equal to its orbital angular speed, and retrograde like Venus. In zone 4, from point 7 to point 1, its orbital speed will continue to increase by twice the orbital velocity difference between distance traveled. This effect is the result of two processes. First, when a body moves inward, its orbital speed is further accelerated by the increased gravitational field, although always brought exactly to the instantaneous orbital velocity. If it moves inward by a distance delta r, its speed is increased by one orbital velocity difference between them. This accelerated motion causes a retrograde rotation, like Venus. Secondly, when a body is pushed inward by a distance delta r, the orbital velocity itself is increased by a difference. This means that its speed has increased relatively by this difference at the target point. However, this enlargement is slowed down by the gravitational field. This creates an effect of prograde rotation. The two effects, one retrograde and one prograde, balance each other out. So in this zone it has no influence on the rotation of Mercury. Its rotational speed remains unchanged as in point 7. At point 1, the distance to the Sun is closest and the orbital velocity is highest. And Mercury's rotation is driven in the other direction. But to be able to change the direction of rotation requires a rotational force greater than the previous rotational inertia, which is equal to the driving force at point 7. According to the principle that the angular velocity of rotation in such a case is equal to the angular speed of orbit, the rotational speed at point 7 can be calculated as follows. This principle also applies to prograde direction, so the rotational speed at point 1 is as follows. This means that the force driving the rotation at point 1 is greater than that at point 7. Therefore, the direction of rotation is changed to the prograde direction. From point 1 to 3 the driving force has decreased. This speed, which has persisted from rotational inertia, remains unchanged. Zone 2, from point 3 to 5, is like zone 4, a neutral zone in which this rotational speed does not change either. At point 5 has a retrograde force that could accelerate the rotation to about minus 1.37 meters second. After point 5, this force will continue to increase until point 7, where the resulting rotational speed will increase to minus 2.14 meters second. It is therefore too small to be able to slow down the ration speed of 3.15 meters second. So this prograde rotational speed of 3.15 meters second can be maintained during the whole orbit. For comparison, its actual rotation speed is approximately 3.03 meters second. We can imagine if the highest rotation speed at point 1 was less than 2.014 meters second, then the previous rotation could not be reversed, and Mercury's rotation would also be the same as Venus's, retrograde. The critical point of the radius around the Sun at point 1 can be calculated using the following equation. By the way, the question of why Venus and Mercury don't have their own moon has answered itself. Because they barely rotate, they cannot power their own satellites. Even if they could obtain one, it would crash into its mother planet. Thank you very much for your attention. See you next time.